All right, friends, welcome to our group code review. We are going to go through this calculating mortgage payment exercise. And we're going to go through we're going to create a solution for this. Now, it's always good before we start to really get to know the question and really what we're going to focus on, especially in this stack, is we're going to have questions and we're going to need to do something to address that specific question. When you get to the BELT exam in 3 weeks, there will be a question asked. You will have a duty basically to where you're going to then have to look at some data and take that somehow and answer the question. And so that's really, really important. So let's get used to that. So it's talking about calculating a mortgage payment. I'm not going to read it because we're all adults. And so you guys can read it. And I will also make sure that I can share this with you real fast. And then that way you guys can follow along. If you'd like, give me just 1 second. Cool. So now this is in the chat for you. Okay. So what it basically is saying is it's talking about how there used to be fixed rate mortgages and now there's a different type of calculation. So we can calculate our monthly payment for a fixed rate mortgage with no points using something called the equated monthly installment formula, or EMI. And that's going to come in because we're going to name a variable EMI. But this is what it looks like below. So if I'm looking at this, here is the actual mathematical formula to calculate this EMI. Where if we see this P right here represents our principal or the amount borrowed, basically how much are we borrowing and taking? If it's a $400,000 house, which is what we're looking at here, we're borrowing $400,000. R is my interest rate over 12 months. And then N is what is my terms, right? Like how quickly am I going to pay this off? Cool. Here's a 30-year mortgage, right? So we have a 360-month term. Usually it's 30 or 15. I mean, I'm not like a mortgage expert, so, don't hold me on that if it's something else, but typically what I hear is 30 or 15. So here we've got a 30-year mortgage. So it's going to say, how would the monthly payment be? How much would the monthly payment be for a 30-year mortgage with a $400,000 principal and a 3% APR interest rate with fees included? So if I were to do this with just, using math and plugging in the numbers into this formula, this is what it looks like, right? To where our answer is $1,686.42. That'd be a dream of a rent payment, to be honest. Living in Seattle, oh my God, I would kill for that. That'd be amazing. Okay, and especially a mortgage, oh my goodness. So here's how we would do it without Python. Now let's go ahead and do it with Python. Before we do that, are there any questions on what we're trying to accomplish here? Cool. So we talked about our different values. We have our P value, our R value, and our N value. Well, it would make sense then, if we wanted to keep track of these numbers, it would make sense for us to create a variable. So here, I'm going to call this P. And in this case, we are reading our question. Our P is our 400,000, our principal, so our amount borrowed. So I'm going to say P equals 4. That's 4,000. 40, sorry, I had to count my zeros. Yep. So now my P is 400,000. Let's go ahead and do my R. Now this is a little bit different. My R is a 3% APR. And if we look at R, it is our interest rate over 12, right? Reminding you, a lot of people make this mistake is they see 3% and they do something like this. Oops, over 12. But realizing 3% is, 3 out of 100. So for dealing with percentages, we've got to do this. It's 0, or even you could do 0.03, where 1 is 100, right? And so anytime you're dealing with percentages, again, a lot of people will just put the number 3, but that's like 300%. So we want to make sure that we are really dealing and knowing, okay, what is the value of my data in the sense of 3, I need to convert that to an actual decimal point, to an actual percentage. Cool. So R is looking good. And then lastly, I have my N, which is my, if I look at this, my term. So number of payments here, we go ahead and give you a little bit of a cheating thing. So my term is, it is a 30-year times 12 And the way I do a times in Python is I do the star right here. And obviously the way I do division is the slash right here. So just so you see that interest rate over that. And then if I'm doing multiplication, I can do this. Whether you have a space or not, that doesn't matter. The computer's going to read the same. It doesn't matter. So for readability, you know, if somebody else is reading my code, sometimes I like to put a space, but it's not going to affect your code. Cool. Any questions with our defining the variables?
So would it hurt if we put 360 there, or do we need to put 30 times 12?
It wouldn't hurt that. It wouldn't hurt at all. So we can put 360 for sure. The reason I'm not going to do that is because what if I did want to do something and to where I wanted to create, I'm trying to not cheat totally. I'm going to end up creating a function that way I can put in any sort of terms
Got
and
it. Right.
it'll do that.
Okay.
If I do 360, that's what we call hard coding it, which is fine. It will technically work, but it's confined to only 30-year mortgages
Okay.
versus if we do it this way, then I can either pass in and create in or something of that nature.
Got
I
it.
can pass in that. So it's totally up to you.
Okay.
So I guess technically 360 is not a big deal because n is that. It's really this would be,
Mhm.
and really I'd put like y or years equals 30. And then I would say years times 12.
Okay. Okay.
If I was really going to like make it malleable, I could do that. So either one
Okay.
works. So I'm going to do this. Oops. The way I did that is if I highlight these and I have a Mac, so I'm command and then the question mark or slash, then that will what we call commenting out our code. So now whenever Google Colab runs this cell, it's not going to read this. So anything commented out, if I did just add this pound sign as well, I can just type that and that'll comment it out as well. So that's just what we call a comment in Python. Okay, so I'm just going to say n equals 30 times 12. I'm also going to just create a comment. It's a good thing to do as we are just sort of explaining what we're doing. So that way, again, if somebody's trying to read our code, we can do that. So I'm say declaring variables. Okay, so I've declared my variables, right? Now, again, we're going off of this. So now I need to actually create my numerator and my denominator. So I'm actually going to create another one called numerator. Now, we are going to try to emulate this guy right here. So I know that 0.03 over 12 is represented by R. So I'm going to say, and I want this all to be in its own confined space. It does do the orders of operation. So knowing that, I can say R times, we're taking this 0.03 that represents R. Then I'm going to say, before I, like if I just were to say like 1 plus R, because that's what this is. If I do this, because of order operations, it's going to do this first and then add R later. So I've got to put this in parentheses. I want this to be calculated before I multiply R by it. And then lastly, I need to multiply it by my n, right? This 360. Now, if I want to create an exponent, I do 2 of these. If I do 2 of these, if I do 2 of the multiplication of the stars, then I can create my exponent and that will mathematically create the exponent. Any questions on what we just did? And then I am missing. Oh, because this is an exponent, sorry. I also want to make sure all of that is done before I multiply by R, right? So I want to make sure that this calculated 1 plus 0.03 over 12 is calculated. Then before I multiply this, I want to make sure that 360 or that value is taken to the power of 360. And then I want to multiply it by R. So that's why I have to have all of these parentheses. Any questions on that? Just make sure the order of my math is in the correct area. Any questions? Does it make sense? Cool. So I've created my numerator. I need to create my denominator. Same sort of thing. Because I have, I need all of this to be done before I do -1. I'm gonna have the 2 brackets. First, I want this 1 plus R. Right? Then I need 2V in. And then outside of those brackets, I'm going to do -1. This makes sure I do 1 plus R. I take that value, I do it to the power of N. So it calculates all of this. And then from that, it takes -1. Now, let's say, put it. Now, if I want to put it all together to calculate our EMI, I'm going to say something like EMI. And again, EMI is estimated monthly installment. I'm going to say EMI of P, because now we're adding this together, right? We're going to try to get this 1686 P times. And because I need my numerator and my denominator to happen first, I put it in a parentheses over denominator. Okay. Now, there's 2 things I can do. If I wanted to see this value, I could print it. Printing is just a very basic way that Python will just basically print or show you anything you're trying to say print to. It's a built-in method. So I can pass in basically a variable or a value or a function. I can print a whole bunch of stuff. In this case, I just want to print my EMI. So I want to print that variable after it runs. So if I do this, I get the 1686,416, which is the 42. So we get our value right there. If I wanted to, I could say round. I take my EMI and I say 2. I need to add another parentheses. And then if I run this, I say 1686,42, just like this. Round is another built-in method from Python, where what it does is it takes in the value you want to round. The second argument it takes in is how many positions do you want to round it to? In this case, I did 2 because it's math, but if I did 3, I could do 3. And it continues to do that over and over and over, but we want to. So I said that there was 2 ways you could do it. You could either print, or in Google Colab, you could just, well, let's see if round will work. The last thing, the last thing here, Google Colab will always just print for you. So I don't have to actually say print. It's just a cheat, but that's only in Google Colab. That's just how Colab works. Cool. Any questions?
So I did mine a little differently. I'm not sure if, would I be able to share my screen just to kind of
Yeah,
show
you
you?
should be able to.
Okay. Let's see. Okay, can you see that?
Yep, I can see it.
So this is how I did mine. I guess I didn't use the proper terms, but I think I took a few more steps than you did. And I did, I guess it looks a little hard coded. So would that be something acceptable this way, or should I try to kind of condense it as much as possible?
Yeah,
like
I
you
would
did?
say it's always a good, and we'll see why in the next one. Having it the way that I had, where we're calling the variables, is going to be really efficient when we're dealing with functions. So if we want it
Okay.
right now, your code works, right? Yeah, I can see that you get the right answer, but it is confined only to a 30-year mortgage at 3% of
Okay.
a house of 400,000, right?
Mhm.
And so if I wanted to create it to where I can do multiple things, or multiple, a house that's 500,000 at 6%, I can create a function that allows that. So usually what what I would opt to when I'm coding is AMI. Is this something that is reusable or like would be reusable? In this case, yeah,
I
right?
see.
Like we're calculating a mortgage. That makes sense. If I work at a company, I'd want to reuse that and sort of customize that. Or if it's not, if you're like, no, this is sort of a one-off thing, then that's fine, right? If you're like, no, this is a specific purpose, that's all it's for,
Mhm.
then that's hard coded and that's okay.
Okay, I see.
Yeah. Great question though.
Thank you.
Any other questions? I'm curious though, it looks like you went ahead and typecasted that to float. What was it coming up as?
I think when I can try removing, forgot the error that it was giving me, but let's see if it works now. I'm not sure, but before I was getting I was getting an error about, I think it was saying something about an integer, and so when I did the integer, it wasn't giving me, dot 41 what and whatnot. So I just used the float option instead.
Yeah. That's what we call typecasting. So what you were doing is you were taking whatever this value was, and you're saying, I want its type, its data type to be a float.
Okay.
So you can do that with an int. You can do that with a string. Yeah. So it's just called typecasting. So I was just curious.
So I think it was because I was before I was using I guess strings, and I think that might have been the reason.
Okay. Yeah.
And I wanted to convert it into either an integer or a float in order to get a number.
Mhm. Yeah. If you have a string, then it's not going to know, it's not going to have any mathematical, capabilities. Now,
Mhm.
one thing that is interesting, and I'd be curious if you tried running this now, what that means is when I'm dealing with an int and then a
Mhm.
float, and we're going to see this whenever we start cleaning data. If that is the case, and I'm trying to do some, mathematics on an int and a float, oftentimes it will automatically convert this value to like a float.
Okay.
So if it is an int, but I'm dealing with float, it'll automatically convert everything to a float. So that way it can do it. It's like built into Python. So I'm curious, can you take off these parentheses on the outside of the P
Yeah.
and then let's run it and let's see what happens.
Oh, I guess it still works.
Yeah. So it looks like it operates and works the exact same.
Yeah. Okay.
Yeah, you
cool.
can even click this and that'll exit it out, and then we can try running it again just to make sure. Yeah.
All right,
Cool.
cool.
Awesome. Okay. We've got just a couple more minutes left. So I do want to share how I would do this in a function. So let me start sharing again. So we have all of this math, right? We already have this ability, but let's say we did want to be able to alter and change the values, right? What I could do is, there's a couple things I could do because Danielle brought up a great question. So we're going to do just a very easy one, and then we're going to make it even more, flexible and durable. So again, if I wanted to create a function, we're going to call this function EMI because that's what we're calculating. Or I could say, like def calc EMI. Either one works fine. Let's just do def calc EMI. That's fine. Well, if I'm calculating my EMI, there is 3 things I have to know, right? I have to know my p-value. So how much money is being borrowed. So let's go ahead and pass that in. I have to know my R value, so my interest rate, and I have to know how long this is for. So I'm going to say N. Now, just know that these values here, and this is going to get very confusing very quickly. So, stay with me here. These are what we call arguments. They can be named whatever you want. They will represent whatever you pass through. But if I called this unicorn, cupcake, and cotton candy, that would work just fine. Now, that's not a great way to write your code because people are going to have zero idea what your code's trying to do, right? So we want to make sure we have good names. But just want to show that you can, I just want to say that you can name those arguments anything. They just represent whatever we pass through, but I'll show you what that means here in a bit. Now, I'm still going to have my numerator. It's actually going to say this, it's going to be the same value. So I'm just going to copy and paste it up here. I'm still going to have that. Ooh. Oh. I did a V versus C. A panic, sorry. There we go. And I'm still going to have my denominator. Right, so I still have these values. And I'm still going to say this. My EMI. I'm still going to have the actual function run. But what's interesting is because I put it in a function, now these values can change. And they're not locked to any sort of specific P value, right? In this cell, these are locked to 400,000, this interest rate, and this years. What I can do now is I can say EMI or calc EMI, because that's what we called our function. So this is my function call. In order for this to work, and you can see even in Google Colab, it's saying, in order for this to work, I must have a P value, I must have an R and an N. Now, Colab has no idea what those represent, but it knows that I need them. This is I did a lowercase p here, so I'm gonna do a lowercase p there. So let's say I wanted to do this 400,000. Let's just do that so we can see. This, because I just didn't put, P equals, because I put this in the first position, this number is going to be associated to this first argument. So they do have to be in order if you don't declare them. Now my R is going to be 0.03 over 12. And my N, this is, and we're going to get less meta here in a bit, is going to be 30 over 12. Now, again, because I put it in this order, it is automatically going to assign this value to the first one, this value to the second one, this value to the N. N now just represents this. That's why I mean, this could be cotton candy, and cotton candy would represent whatever the third value passed in means. So now if I run this, okay, nothing happened because I didn't return EMI. Now my function ran, it calculated it, but it didn't do anything with it. In order for me to actually see it, because this is the last thing, I can do this. And now I get this guy right here. I could even say, if I wanted to, in my return statement, I could say round EMI 2. And it'll get me that value. Okay. I could go even more where I say, okay, this is P, R, N. I could even say, well, P makes sense, right? I'm just going to pass in this value, so I don't need to necessarily change that. But instead of doing this, what if I wanted to do just whatever the percentage is, right? So you pass in a whole percentage, like 3%. Well, what I could do is, let's say I call this interest. Well, what I could do is I could say R equals, because I'm using R down here, interest divided by 100. Over 12. So now instead of having to do the mathematical, instead of having to do the math here, I just pass in this guy. It's 3% interest. It's going to take 3 divided by 100. It's going to give me the 0.03, and it's going to divide that by 12 to calculate my R. Same thing with N. So maybe if I want to say N is just my years. So I might just say years here. I'm going to say N equals years times 12. So now if your mortgage is 30 years, it's going to take that value. It's going to create this variable R and N. So if I run this, I should get the exact same value. Yep. But now what if my house is 600,000, 6.5 million at a 4% interest over 30 years. My rent, good Lord, is $31,000 a month. So now we've created a function that people can pass in. They can pass in any values and it works with any sort of mortgage. Any questions on that? And honestly, if I was writing this, I would probably call this principal. And then for the, I can say print. But actually, let me just say this. Just to show you that unicorn represents the value being passed through. I still get the same number. So these argument names can be whatever you want them to be. Obviously, that doesn't make sense. So if I were looking at your function, you'd be like, what the heck are you talking about? But now that gets me the value. Any questions? We're a little bit over time. Any questions on this assignment and how you could do that?
Just to confirm, in order to print out your results, the return would have to be included within that block of code or function, I guess.
Well, yes, technically. Because what happens when I have a return in a function is whatever is being returned becomes the value of this function call. So if I were to say something like, X equals this, and then I say print, or because it's Google Colab, I don't have to, I'm still going to see that because this function, whenever Python reads this, it says, okay, function, I have all the information I need. It stops everything it's doing. It goes and finds that function, runs it. And because I return whatever's being returned from this function becomes the value of that function call. So now X equals whatever is being returned from this function call, which in this case is 31,031.99. If I didn't return it, it's going to run and it's going to find out everything, but I'm not going to have any sort of information. Now, if I didn't return and I just printed, this is going to print for sure. Well, it's not going to do X because X, it's probably going to give me an error because it's, oh no, yeah. So it still printed it, but X isn't anything because X doesn't, this doesn't return anything. So if I got rid of this, it's printing this and I'm seeing it. But if I said something like print X equals none. The X equals none because this doesn't return anything. Therefore, the function value is none. If you don't return anything, it just by default is none. But
Okay.
I can still see that value. But again, printing is just really for the developer. It's not for anybody's or any use other than you being able to see. Make sense?
Yeah, it does.
Cool. All right, friends. Well, that's all I've got for you. I'll stop the recording here.